Mr. Baker's house of knowledge.
Excellent. So today we're going to start talking about a thought process that needs to occur when we're working with proofs that deal with overlapping figures. So what I've done here is I've got the original drawing. Now this came from a problem that was out of the book. So let's just take a look at what the problem looked like in the book that we're going to be doing. It was an origami problem. Origami. Oh, here it is. So this is the picture and this is the problem that I took from the book. And we're going to prove some stuff about this figure right here. We're going to use a two-column proof because I like two-column proofs better than paragraph proofs. All right, so the first thing you want to analyze when you're talking about how to do these proofs that get a little bit more complicated is you want to know what it is. You need to kind of think about where you're going. So what I like to do is I usually like to highlight what I'm trying to prove at the end. In this case, I'm trying to prove two triangles congruent. So I'm going to highlight those triangles. One of them is triangle GED. And then the other one is triangle JEB. So I'm trying to prove the green triangle congruent to the yellow triangle. And of course, there's already something that my eyes have immediately gone to that I will probably use in my proof, hopefully. So the first thing I'm going to do is I'm going to make an auxiliary drawing that just includes the two figures that I'm trying to prove congruent. So I'm going to do an auxiliary drawing of triangle GED, and I'm going to do an auxiliary drawing of triangle JEB without all of the other stuff in there to get in my way. And then as I write the statements here, I'm going to mark them on whatever drawings are applicable to mark them on. All right, so of course the first statement is going to be what? E is midpoint of AC and DB. Now, that's my given information, so my brain is already starting to trigger here. Surely they wouldn't give me any information that I would never possibly use in my proof. And the only thing that they've given me is two segments that share a midpoint. And I know that I'm trying to eventually prove triangles congruent, so I know I'm going to need to collecting information about sides, and I'm going to need to start collecting some information about angles. Well, what does a midpoint do? It divides a line into two congruent parts. So the first place my brain is going to go is I'm going to say, you know what? I probably need to do something with the midpoint. And in this case, the midpoint breaks AC up into two congruent parts, AE and EC. And then E also breaks DB up into two congruent parts, DE and EB. And that is by what? What reason did I just use there? Definition of what? Well, I mean, definition of a midpoint. Yeah, midpoint and bisector are kind of the same thing. But you're okay. All right, so definition of a midpoint. So now I've got something I can mark on my drawings. I can mark AE congruent to EC. I can also mark DE congruent to EB. And in fact, DE congruent to EB will get marked down here. And I have already recognized that I am probably not going to be able to create enough information here to figure out that these two triangles are congruent. So I've already kind of started a sketch of another figure down here, but I'll show you why I went here in a second. Yes, ma'am?
So when you're proving the triangles, you, like for these, it's always by one of the 5 ways.
Yes.
And then when you're doing an angle, it's by CP,
CPCTC, corresponding parts of congruent triangles that are congruent, is used after you know that you have two congruent triangles. So it takes three pieces of information to say that two triangles are congruent, and then once you know they're congruent, you have 6 pieces of information, because now you have all the sides and all the angles.
So when it says, like, if it's a CPTC, it's like, it says prove, and then, like, so you have to prove a way of the triangle first, and then prove that?
You have to have in your statement somewhere that two triangles are congruent before you can ever use a CPCTC. Absolutely. Good point to illustrate there. All right, so to me, I'm trying to prove these two triangles congruent. That's my auxiliary drawing. So my brain's thinking, well, I already see something just right off the bat. I can just see with my eyes, but by examining the drawing, that angle GED is congruent to angle JEB. And notice that I kept the corresponding things in the same order, even though with angles you don't have to do that. I just am now in the habit of doing that, and that makes it easier when I write my triangle congruency statements. Why would those two angles be congruent? Right, so vertical angles are congruent. You want to make sure that you say that they're congruent. So I'm going to go ahead and mark that. I'm going to mark that angle congruent to that angle. I can even go to my big drawing and show that that angle is congruent to that angle. So I've got an angle and a side. I need to either pick up another side for side angle side, or I need to pick up another angle. Either these two angles would work for angle angle side, or these two angles would work for angle side angle. I don't think I'm going to be able to get side side side, mainly because I've already got an angle. And so since I'm already picking up some information, and sometimes information is pretty hard to come by, side 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 would be the last thing that I would look at. Since I don't really have any information to indicate that any of these triangles are right triangles, I'm not even going to be looking at hypotenuse leg either. So right now I'm going to be focusing on either trying to find a way to find GE congruent to EJ, or I'm going to try to find a way to prove that angle D is congruent to angle B, or angle G is congruent to angle J. Well, I don't have a whole lot of information about this line GJ. So this is really what led me to make this other auxiliary drawing. For some reason, it was important that E was the midpoint of AC. So when I look at this line and these two things being congruent, and this line and these two things being congruent, it kind of led me down the path of maybe I should be looking at triangle AED and triangle BEC, or I guess I should have said triangle CEB, and see if I can't get these two triangles congruent. Because I've already got this side congruent to that side, and that side congruent to that side, and my eye is immediately drawn to the vertical angle. So I think I'm going to use this vertical angle reason again. I think I'm going to say that angle AED is congruent to angle, and now I'm going to keep my corresponding parts correctly. What should go first? What corresponds with A? E, C. C touches the one marked line. B touches the 2 marked line. A touches the 1 marked line. D touches the 2 marked line. So C is corresponding with A, E corresponds with itself, and B corresponds with D. It wouldn't be wrong if you wrote BEC, because we're still just talking about an angle, and BEC and CEB are the same angle. However, I want to get in the habit of keeping my corresponding parts congruent. So that's true by the same reason we just used, that vertical angles are congruent. Now, I don't have a way to mark that on this drawing. I could mark that on this drawing, but it would start to get confusing because I would have arc marks going through lines, and that's just messy. So I don't think I'm going to bother to mark this information on other drawings. However, now that I have that information, I can say that triangle AED is congruent to triangle CEB. And this is the one that would get marked wrong if you didn't have your corresponding parts matching up. Why are these two triangles congruent? Side, angle, side. It's really easy to see why they're congruent now because I've pulled them out of a drawing and I've just looked at them. All right, so now that we have proved that the two triangles are congruent by side, 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 and just to kind of review, the reason I said that was because I knew that I was dealing with the midpoint of AC, so I knew there was some reason that I needed AE and EC. So that led me to use this auxiliary drawing, which led me. So now, what information can we get out of this drawing that maps directly back to this drawing? Can anybody see the thing that this auxiliary drawing and this auxiliary drawing have in common? They both have line DB, and in fact, they both have angle D and angle B. And we don't have any marked information about angle D and angle B yet, but if these two triangles are congruent, what do we know about D and B? Why would they be congruent? Right. So angle D is congruent to angle B. And by the way, I can get away with that because in each of the drawings that I have, there's only one angle at angle D. There's only one angle at angle B. So I don't really have to be more specific with that. And that's by CP, CT, C. Excuse me, corresponding parts of congruent triangles are congruent. So that means that that's congruent to that. I guess I need to use 3 Archie markies. And so I'll go ahead and mark it here. 1, 2, 3. 1, 2, 3. Those two. Oh. Well, now what do we know about these triangles? Right. And now I can say that triangle GED is congruent to triangle JEB. And the reason for that would be angle, side, angle. So sometimes if you know where you're going, if you just kind of keep messing with the material that you've got, you'll wind up getting there and you'll be like, oh, wait, I'm already done.
Yeah, for 7 steps.
Yeah. You know, the next one's 9 steps, so 7's a bonus. All right, any questions about my thought process about what I did here, or any of the steps that we took, or any of the reasons that we came up with? Yes, ma'am.
Is it okay, like when you write E and B, like angles, is it okay if we do like EJ, just to get the habit of it?
Yes. I think I hear what you're saying, and the answer is yes. So I think what she's asking is it okay if right here I did AD, B, and CBD instead of just doing D and B? Is that what you're asking? And that's fine. The naming of the angle just has to be an accurate representation of the angle you're talking about. And it's always appropriate to name an angle with 3 letters. Just make sure the center letter is your vertex. All right, that was so much fun. Let's do another one. So in this problem right here, we start out knowing that PS is congruent to RS and angle PSQ is congruent to angle RSQ. And so that's marked on this drawing right here. I went ahead and pulled apart the 2 things that I think are going to be the triangles that we have to prove. So that's triangle P, or triangle QPT, and I'm going to try to prove that congruent to triangle QRT. All right, so of course the first thing I'm going to do is I'm going to use my given information. So PS congruent to RS, and angle PSQ congruent to angle RSQ. And that's given. Well, I don't have any information at all about these 2 triangles that I'm getting ready to prove. I can already see that they share a side, and so those sides are going to be congruent by reflexive, but I don't have completely any other information at all. So I think what I'm going to do here is I'm going to start working with these two triangles that I do have information on and just see what I can do with them. So my goal right now is to take a look at triangle PTS and triangle RTS. And I already know that PS and RS are congruent, and I already know that this angle PST and this angle RST are congruent. I think I can get those two triangles congruent. Anybody got an idea how I would do that? Yeah, I'm hearing TS is congruent to TS. And what's the reason for that? Reflexive. Right, they shared this side, so those two sides would be congruent. And now, do I need any other information? Nope, now those triangles are already congruent. So that's going to be triangle PTS is congruent to triangle RTS. And what would the reason be? Side angle side. We okay with that? So now, the question I now want to answer is, what information do I have in these two triangles right here that also is in these triangles right here? Yeah, they both contain TR and TP. So I think what I'm going to do is I'm going to say that PT is congruent to RT. And what reason would I possibly use for that? Why would I say that these two sides are congruent? C, P, C, T, C. CP, CTC. All right, so that makes this, I'll go ahead and put 3 marks on it, congruent to this, and I'll go ahead and put 3 marks on that. So this is congruent to this. All right, trying to prove these two triangles congruent, I guess now's as good a time as any to throw out there QT is congruent to QT. And that would be why? Reflexive. All right, so that's congruent to that. And this is usually where people in this particular proof stall. So, what have I been kind of telling you guys to do every night? Don't make them every night. Use them every night. Review them. Move through them. So how many people have a complete set of note cards? Oh. How many people have any note cards? How many people look through them on a regular basis?
I look through them once or twice a week.
Once or twice a week I would consider that regular. So, why is it important to have a complete set of note cards? And why do you think your note cards are not complete?
Because note cards help make you smart.
I don't know if I agree with that. Note cards are going to help you remember stuff. And we've got a rule now that we really need to know. And it's not a rule that's been used a lot like reflexive or definition of congruency. It's a rule that I'm not even sure it's obvious that we apply. So I'm just going to go ahead and walk you through it. I don't know how to tell you to get good at this obscure stuff other than if you have a bank of knowledge of rules that you can use, you can kind of cycle through. So my thought process on this one was, man, it would be really great if I could come up with a third side or an included angle. Since I've already got two sides, it seems to me like side, 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 or side, angle, side would be one of the two logical reasons to use. So I'm looking at this picture, and I looked at it for a long time, and I couldn't think of any way I could get PO and RO congruent to each other. I couldn't figure out a way to do it. And I almost gave up on getting this angle congruent to that angle too, until I realized they were both linear pairs with corresponding angles and triangles that I know congruent. And so that's what kind of keyed me into the first thing I want to say is that angle PTS is congruent to angle RTS, and that was by CPCTC. So now I know that this angle right here is congruent to this angle right here. And now if these two angles right here, I'm going to go ahead and mark this on this drawing too. If those two angles right there are congruent, and this angle is supplementary to that angle, and this angle is supplementary to that angle, there's this really obscure theorem that we haven't used really. I don't even think we've used it yet at all in anything. But there's a theorem that says if two angles are supplementary to the same angle or supplementary to congruent angles, then those two angles will also be congruent. It's called the congruent angle supplement, the congruent supplements theorem. And so that's what I'm going to use. So the first thing I need to say is, I need to say that those angle combinations are supplementary. I need to link angle PTS and angle PTQ as supplementary. And I need to link angle RTS and angle RTQ as supplementary. What makes those pairs of angles supplementary? That's another one that we used a lot right away, and then we haven't used it really since. What? Linear pairs. Linear pairs are supplementary. You could just put linear pairs. I'll know what you're talking about. Linear pairs. So that makes that angle supplementary to that angle, and that angle supplementary to that angle. So now I can say that angle PTQ is congruent to angle RTQ, and that is by the, I'm going to use the symbol instead of writing out the word. That is called the congruent supplements theorem. That makes this angle right here congruent to this angle right here. And now why would those two triangles be congruent? Right. So now you can say the proof statement. Triangle QPT congruent to triangle QRT, and your reason is side, angle, side. So this is what I would call a pretty difficult proof. And the reason it was difficult is you had to extract that linear pair thing, and we haven't looked at pictures yet, or we haven't looked at pictures recently and pulled out the fact that things are linear pairs. And I don't think we've used the congruent supplements theorem in a proof yet. So just because we haven't used it doesn't mean it's not going to crop up. So once again, I'm going to encourage you to complete your note card set and review them a lot, because then that's what I did when I was working through this one. This one stumped me a little bit when I first went through it, but I know all of these rules pretty good. I don't flip through note cards anymore. I've just been teaching it so many years that they're just kind of ingrained in my brain forever. I'll be like 80 and in a nursing home and drooling, and I will know the congruent supplements theorem because it's emblazoned upon my brain. So that's pretty much probably one of the most difficult types of proofs you can get. We did another proof a couple of days ago where you had to convert everything to equals and subtract off a common side and then convert it back to congruency. That's what I would consider a difficult proof. These are the types of proofs, in my opinion, in an honors class that separate the A students from the B students. So if you want an A in this class, this is something that you should be able to do. One of the ways that I might make this problem easier is I might work this out and then just put the statements down, and then you would have to supply all the reasons. Once again, you'd still have to know these hard reasons like congruent supplements and linear pairs, but maybe if you had all the statements, this would be a lot more doable and less intuitive work for you. So that's basically what we've got tonight, is basically working some of these proofs. They're going to be a little bit more involved than the proofs we did the other night. And then tomorrow we'll come back and go over those proofs. And then I've got some more stuff to give you over this section.